Third video is going to deal with a bit more notation as well as a couple of definitions. So if we're looking at the point where we have initial point 0, 0, and a terminal point of some point xy, we can write that vector using these angle brackets around them. And angle bracket xy, close angle bracket would be the proper notation to do that. Again, that's if we're starting from point 0, 0. You can use this notation as well, provided that you show the differences that you have there. So if you have an initial vector, some xi, yi, and a terminal terminal point, initial point and terminal point, xt and yt, you can express the vector v as components, and the component for the x value will be the change in x, which will be xt minus xi, and that's going to look very similar to x2 minus x1 from something like a slope form. Similarly, the change in y will be yt minus yi, where we ended up minus where we started. The final definition that I'm going to show you on this video deals with what we can do with component form when we're doing the scalar multiplication. So we've got this vector v, which is some x1, y1, and another vector w, which is a different, well, potentially a different x, but x2, y2. They could be the same, they could be different. Scalar multiplication for some scalar k, we simply distribute that k into our vector. So k times the x value and k times the y value. K times the x and k times the y. And if we add the vectors together, again, what you probably would expect component-wise is going to work. We take the x values and add them up, and then we take the y values and add them up for the second component.